Hi there, grade 10. So last time I was able to discuss to you the different parts of a circle. So this time I'm going to discuss some properties on arcs, chords, angles, and inscribed angles. But before we proceed to that, let us recall some of these terms which are needed or necessary as we prove some theorems as regards to the properties of the chords, arcs, central angles, and inscribed angles. So when we say isosceles triangle, so this is a triangle with two equal sides. So if these are the two equal sides, these are the base angles, and the base angles are also congruent. So the base angles are congruent. Now we define congruent angles as measures of congruent angles are equal. Now, the exterior angle theorem explains that the exterior angle, for example, in this illustration, D equals the sum of the two remote interior angles, A and B. So that's exterior angle theorems. Now, with the right triangle congruence theorems, the two right triangles are congruent if we are able to prove that the six corresponding parts of the two right triangles are congruent. But with these theorems, by only proving two corresponding parts to be congruent, then we can say that the two right triangles are congruent. So under the right triangle congruence theorems, we have hypotenuse acute angle. So if the corresponding hypotenuse side and the corresponding acute angles are congruent, then we can say that the two triangles are congruent. Leg, right triangle congruence. So if the legs of the corresponding parts of the right triangles are congruent, then the two are congruent also. So we have LA, so that's leg acute angles. So all these are considered as right triangle congruence theorems. Now with triangle similarity theorem, so we can say that the two triangles class are similar if the corresponding angles are congruent and the corresponding sides are proportional. So when we say proportional, their ratios are equal. Now with triangle similarity, proving only two corresponding angles of the two triangles to be congruent, we can say that the two triangles are similar, and this is based under the angle-angle triangle similarity. Now with side, if we are able to prove that the three corresponding sides are proportional, then we can say that the two triangles are similar. Another triangle similarity is the side angle side triangle similarity. If the two corresponding angles are congruent and one corresponding side, which is the included side, so when we say included side, the side should be in between the two congruent angles, must be proportional. So we can say that the two triangles are similar. Another thing that we have to know is the definition of vertical angle, or what are vertical angles. So vertical angles are congruent. So vertical angles are the result of the two intersecting lines. Okay. Vertical angles are the same with opposite angles. So this is one pair of vertical angles and the two are congruent. Another pair is this one. So the two are congruent also. Now another is the transitive property of equality. So when we say transitive property, if let's say A equals B and then B equals C, we can conclude that A is equal to C. A B and C here are all elements of real numbers. Okay, so let's proceed with the first property, and it's about arc addition postulate. So this is similar to segment addition postulate, but of course we're talking of arc here. So if a point is placed on a given arc, so let's remove this H of a circle, then that point divides the original arc into two smaller arcs whose total measure is equal to that arc of the original arc. So for example, we have arc PQ here. So the measure class of arc PQ is equal to the sum of the two smaller arcs, arc PQ and arc QR. Take note that the point referring here is point Q. So arc PR here is divided by a point, which is point Q, for instance here. And arc PQ is divided into two smaller arcs. So not necessarily this point Q has divided P arc PR into two equal parts. So this arc is divided by Q in such a way that the measure of arc PQ equals the sum of the two smaller arcs. So that's arc addition postulate. Now we have central angle postulate. So we define a central angle, an angle whose vertex is the center of the circle. Now, the measure of a central angle is equal to the measure of its intercepted arc. So in this example, we have central angle AOB. So the measure of angle AOB must be equal the measure of its intercepted arc AB. And that's central angle postulate. Now here, we have the inscribed angle theorem. So we define an inscribed angle. An inscribed angle has vertex on the point of the circle. Now, as regards to inscribed angle theorem, it says here that the measure of an inscribed angle is half the measure of its intercepted arc. So this is what we're going to prove, is the measure of angle C here, which is an inscribed angle, really equal to half of its intercepted arc, BD. Now, we're going to prove this theorem by completing the table here. So the first reason from the statement on the left side, so this is given. Now, circle A has inscribed angle BCD, so it's in the given. Now, line segment AB and line segment AC are radii of circle A. So the two radii were constructed here. So we can reason out that the two were constructed. And then AB, line segment AB is congruent to line segment AC. Why? Because the two are radii of circle A. So here, radii of the same circle are congruent. Now, triangle ABC is an isosceles triangle. So this triangle is isosceles because of the definition of isosceles triangle. So an isosceles triangle has two equal sides. Now, in the previous statements, we have really verified that the two line segments here are congruent. The two radii of the same circle A are congruent, and these two radii are actually the sides of this triangle. So really, this triangle is an isosceles triangle based from our definition of isosceles triangle. Now, the measure of angle B is congruent to the measure of angle C. They're congruent because they are the base angles of this isosceles triangle. So the base angles of isosceles triangle are congruent. Now, since the two angles are congruent, so we can say that their measures are equal. So this is about definition of congruent angles. The measure of angle BAD, so let's construct angle BAD here. So the measure of angle BAD, which is this one, equals the measure of angle B, this one, and angle C. So what's the reason for this one? So this is about the definition of exterior angle theorem. Angle BAD is an exterior angle, and the measure of an exterior angle is equal to the sum of the two remote interior angles, which are B and C. So this is about the definition of exterior angle. Now, the measure of angle BAD is twice the measure of angle C. So instead of writing, so from the previous statement, it's clear that the measure of angle B plus the measure of angle C equals measure of angle BAD. Also, measure of angle B equals measure of angle C. Now, in statement number 8, the right side becomes twice the measure of angle C. So angle B here was substituted to angle C. That's why we come up with twice the measure of angle C. So this is due to substitution. So we substitute the value of angle B to angle C. Now the measure of angle BAD equals the measure of arc BD. So where is angle BAD here? So this one. So this is a central angle, and the right side of the equation is its intercepted arc BD. So their measures are equal, and this is from the definition of central angle postulate. And then twice the measure of angle C is the measure of arc BD. So we replace the left side by using twice the measure of angle C, which is equal to the measure of angle BAD. So we did some substitution. So this should be substitution. Now, let's refer 11 from statement D. So from statement 10, we come up with statement 11. So we have constant 2 factor on the left side, and this was canceled, and we got one constant 1/2 factor on the right side. So this is because we multiplied both sides of the equation in statement 12 by 1/2. So multiplying 1/2 to 2 makes this 1. So we have 1m, or measure of angle C here, equals 1/2 measure of arc BD. So we multiplied the same value, which is 1/2, on both sides of the equation. So to come up with 11. So this is multiplication property of equality. Really, measure of angle C here, which is an inscribed angle, equals 1/2 the measure of its intercepted arc. So this is about inscribed angle theorem. Okay, so for semicircle theorem, now let's call this circle A, and this is point B, C, D, E, F, G. Now, it says here that an inscribed angle that intercepts a semicircle is a right angle. Now, we have two right angles here, and we have to verify if they are intercepted by a semicircle. So this one is a right angle because this is intercepted by a semicircle EBC. Okay? And another right triangle here. We have triangle EBC is a right triangle also because this is intercepted by semicircle EDC. So, angle CDE and angle CBE are right angles because they are intercepted by semicircles. So that's for semicircle theorem. So this semicircle theorem is again a special case on inscribed angle theorem. Okay. So we have the bisected chord theorem. So if a radius of a circle is perpendicular to a chord of the same circle, then the radius bisect that chord. So when we say bisect class, the chord is divided by or divided into two equal parts. Okay? So this is the radius and this is the chord, and the two are perpendicular based from the given here. So circle A with radius AB. So AB is perpendicular to CD, and then AB intersects CD at X. So we have to prove really that line segment CX is congruent to line segment DX. So from these statements, so the last statement here will really tell us that the two are equal because this chord CD is bisected by AB because the two are perpendicular. So here, so the first statement, these are true because these are given. And then angle AXC and angle AXD are right angles. So AXC and AXD are right angles. Okay, so they are right angles. Why are they right angles? Because the two line segments are perpendicular. So this is about definition of perpendicular segments or line segments. So perpendicular lines or perpendicular line segments create 90-degree angles, and these are the 90-degree angles created by the two perpendicular line segments. Now, angle AXC is congruent to angle AXD. AXC is congruent to AXD. Yes, they are congruent because all right angles are congruent. Okay, this one is AX. Line segment AX is congruent to line segment AX because AX is the reflection of itself. So they're equal. So this is about reflexive property. Now triangle AXC. So let's create this side and this side. So triangle AXC is congruent to triangle AXD. Okay. So I have recalled some right triangle congruence theorem. So we have one already. So this is the leg. Okay. And then we can say that the second corresponding sides are congruent. So the hypotenuse AC is congruent to AD. because they are radii of circle A. So therefore, triangle AXC and triangle AXD are congruent because of HL right triangle congruence theorem. Okay. Now, this side and this side are congruent. Why? Because we were able to prove that the two triangles are congruent. Therefore, the corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. So really, bisected chord theorem is true based from this proof. Okay. So we have the intersected chord theorem or intersecting chord theorem. So if two chords of the same circle intersect, then their point of intersection divides each chord into two segments whose product is the same for both chords. So for instance, here we have line segment AB and line segment CD, which are both chords of circle X and they intersect at X. So we have to prove that AX times BX equals CX times DX. Okay. And with that, we will be able to prove that this theorem is really correct. Okay, so the reason for the first statement is given. Now, angle AXD is congruent to angle BXC. Okay, so this is AXD, and this is congruent to BXC because the two are vertical angles. So, definition of vertical angles. And vertical angles are congruent. Chord AB, this one is AD class. Chord AD forms triangle AXD, while chord BC form triangle CXB, and this is construction. Now, measure of angle A equals this one, angle A, 1/2 its intercepted arc BD. Okay, so this should be 1/2 measure of arc BD. Also, measure of angle C, which is this one, is equal to 1/2 its intercepted arc BD also. And this is because of inscribed angle theorem. Okay? Now, measure of angle A equals measure of angle C. So if, again, from the previous statement, measure of angle A equals 1/2 measure of angle arc BD. So we assign, for example, the left side equals A here, while this one is B. And then measure of angle C, we assign this as B, while this is C also. Okay, so this is about transitive property of equality. Now, if the measure of two angles are equal, angle A and angle C, then we can say that they are congruent. And this is about the definition of congruent angles. Now, triangle AXD is similar to triangle CXB. So let's remove one triangle here. Why? because we have two corresponding angles to be congruent. So this is the first pair, while this one is the second pair. The two are congruent here also. So this is about angle, triangle, similarity, theorem. Now AX all over CX, AX all over CX are equal, as well as CX all over BX. Why? Because corresponding parts of similar triangles are proportional. We were able to prove that the two triangles are similar. So the other corresponding parts also are similar. And that's for statement number 8. Now, how did we come up with number 9? So we cross multiply previous statement and we did multiplication. So this is about multiplication property. So really, AX times BX equals CX times DX. So that proves that intersecting chords theorem is correct. Now, how about applying the theorems and postulate that you have learned for us to solve for this? Okay? So, how do we work on the measure of angle A? So, measure of angle A here is equal to 120 less 60. I'm sorry, 180. Because the two angles here are supplementary or they're linear. So, measure of angle A must be 120. Now, this one is measure of angle E is equal to 180 less the sum of 90 because angle DAC is a 90-degree angle less 52, which is the measure of angle BAC. So we have 38 degrees. For this one, so we will be able to work on the degree measure of NP, since we know that NP here is the intercepted arc of inscribed angle NLP. So twice measure of angle NLP equals twice its intercepted arc. So 68 times 2 will be its intercepted arc. So measure of arc NP is equal to 68 times 2. So we have 136 degrees. Okay? So this one is 136 degrees. Now, how about the measure of angle LNP? So measure of angle LNP is 1/2 its intercepted arc. So 1/2 of 92 equals 46 degrees. So we have 92 divided by 2 equals 46. So therefore, this one is 46 degrees. Now we can work on the measure of arc ln. Okay? So measure of arc ln equals 1/2 or twice, rather. This is twice the measure of angle LPN. So we have to work on the measure of angle LPN first. And measure of angle LPN is equal to 180 less 68 less 46, because the sum of the three interior angles of a triangle is 180. So we were able to identify the measures of the two interior angles. So we'll be able to work on the measure of angle LPN. And so this is 180 less 68 less 46. And we have 66 here. Okay. So this is 66. If this is 66 degrees, LPN is 66 degrees. So arc LN is equal to 66 times 2. So this is, so measure of arc LN equals 2 times 66, which is equal to 132 degrees. Now for this one, this is an inscribed angle, while this one is its intercepted arc. So we'll be able to solve for x by equating or by considering that the measure of inscribed angle is 1/2 of its intercepted arc. So if we're going to multiply both sides here by 2, so we have 6x plus 50 equals 5x plus 60. So we have 6x minus 5x equals 60 minus 50. So x equals 10. If x equals 10, then this inscribed angle measures 3 times 10 plus 25. So this measures 55 degrees, while its intercepted arc measures 110 degrees. And really, this measures 110 degrees. Okay? So we're done.